Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. Today, we're going to be talking about the map function, which is part of the standard algorithm. So super cool stuff that we have coming ahead here. Let's go ahead and dive in and talk a little bit about this. So today I'm going to take us to the documentation and the library reference, and we're going to be looking at something that's considered functional or functional in practice, the map function, which many of you may be aware of, but it's actually found in algorithm here. So I'm going to go ahead and click on algorithm. We'll go down to iteration here, and you'll see that the map function, if I go ahead and just highlight it here, has to deal with, well, iterating through elements. So it's very similar to a for each loop. Now, why do we use map, for instance, versus just a regular for each loop? Well, as you can tell here, it makes for one-liners. It's very easy to use, and it's very easy to compose, which we're going to see, and reuse and build actual functions, where we perform some amount of work to each element in some container or collection. So what exactly do I mean by that? Well, let's go ahead and say we have this array here, which I've set up here with a few different elements. And of course, in memory, it looks something like this, where I've got 1, 2, 3, and 4 in my contiguous array. So something that I could do is write a for each loop here, for each element in the array, and then we would do something. Maybe we would double each element here, element times equals 2. And of course, in D, remember, if we want to actually affect the array, we would do ref here, but let's just not worry about that. Let's just say we're going to do a right line or something, and we can perform this code. So immediately, there's a few different things that we have here. One, we like for each loops because they're very intentional. It's saying for each element in this array, do this particular body of code here, whatever we have here. But we can do the same thing with a map function. And map, again, is very explicit. It's, again, explaining exactly the operation that we're going to do. But again, where map is useful, so go ahead and just put map here, because that's what we're going to be talking about, is for, one, what if I want to save this result here? Well, we saw how we could do something with ref here, and that would actually mutate this actual array here. So instead, though, we could use map, which allows us to save the result here. And it's also a bit more composable. Okay. So that's sort of the advantage. It also reads well. It also can make some of our code a little bit cleaner. So I'll just kind of put that as a, plus minus, sometimes cleaner. And sometimes in different programming languages, map might also have parallel versions. So I'll put a minus and a plus here, parallel. Although with D, we can do for each and parallel loops, maybe that you've seen some of that, but then you have to start thinking about race conditions and so on. So anyways, those are some of the advantages in thinking about map and why we have this construct versus just for each, for instance. But let's go ahead and take a look at it in the D documentation. So from the first example, what I see here is map, and we can see that this is actually templated. So we haven't really talked about in depth what templated functions are, but basically what that's going to do here is perform this lambda or some callable function, some operation to each element in our sequence or array or whatever the collection is here. Now, the documentation is doing something kind of interesting here where it's chaining a few of these elements here together. And then calling a function. So I'll go ahead and start us off with a simpler one. The basic idea is that we're just taking for each of our elements in our array. So let's look at this example here and just multiplying them. 1 times 1, 2 times 2, 3 times 3, 4 times 4. So calculating the powers here. Okay, that's what this a times a is doing. So we can pass in a function here. We could pass in a string that, if evaluated at compile time, acts like a function. So there's different ways that we could do this with map. So let's go ahead and take a look at a few examples here, and we'll see some of the different powers of map here. So let's go ahead and just start off with a basic map here. I'm going to go ahead and just recreate that array. It'll be a dynamic array for us. And let's just use 1, 2, 3, 4 for now. And let's go ahead and use that map function. And I'm actually going to put it within a right line just so we can see some output. So let's go ahead and do array.map exclamation because it's a template. And let's go ahead and do that same thing, a times a here. That is the lambda function that'll be applied to each of these elements, 1, 2, 3, 4. And let's go ahead and try this out here. And immediately we can see we get 1, 4, 9, 16, because again, 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. So that's the basic idea here with map. And again, we could alternatively, if we wanted, do the for each element in our array, and I could write out the element times element, for instance, and we would get something similar here. Oops, if I make sure to spell everything. But you will notice that there is a difference here immediately, and that I would need to build some sort of collection here as I'm just writing things out. So I need to either allocate that or make a decision about modifying the original array here. So that is sort of one of the advantages here with map. So in fact, let's go ahead and see if we can do that. So I'll go ahead and just say the equivalent idea here for what we're doing. But we are not saving our result. Whereas here, we can save our result here. So let's go ahead and try it out here, first and foremost here. So let's just go ahead and call that function again, map, and I'm gonna do a times a, and I wanna save it here. So let's go ahead and save it to array2, and let's see what happens here. So I'll go ahead and try to run this, and oh boy, I get an error here. What did I do? It says error cannot implicitly convert an expression map with the array. And again, I'm taking advantage of the universal function call syntax. So array would be the first argument of map here. Let's go ahead and that may not be highlighted here very clearly, but again, that's what's going on here. But it says it's unable to convert this expression of map result with a lambda. Again, that would be our function, and then the type here to this integer array. But I'm pretty sure when I ran this before, if I go ahead and look at this, that I did get something that, well, looked like an array here. So I've got to talk about this a little bit more, perhaps later on. I'll quickly bring in a page from the D documentation here, just to again show map. It is returning something known as a range. We've got to talk more about ranges, which is different than an array, okay? And this is actually a powerful idea in the D programming language. Again, we need to talk about this a little bit more, but this allows us to evaluate things lazily or have infinite sequences and so on. So basically, that's a way to say we need to actually convert this result into an array. Okay, so how do we do that? Well, we have a tool for that. Let's import the standard array. This is something that I think trips up beginners initially when using the standard library, but we just do dot array, and that will evaluate this as an array here. And now we have array2. So let's go ahead and write out that result here, array2. And you can see we have 1, 4, 9, 6, and so on. Okay, so another question is, are these actually different arrays here? If I look at array2 and modify one of the elements in array here, did I create a copy of this here? Well, we could do a little experiment here. And we'll just write out both the arrays. I'll modify one of the elements, say in array2, and set it equal to, say, 9 here. And you can see that we have different arrays. Okay, so this is effectively, when I do the dot array, it's creating the copy of the array. Again, maybe we'll talk about this later, but let me drag in a help page for you if you want to search std array, and you'll see that this array function returns a copy of the input with a newly allocated dynamic array, which is what we want, and it matches this type here. Okay, so that's pretty cool here. And the last thing that I'll show you with regards to this is, again, just to look at the type ID. Let's not forget about that tool. We haven't used it in a while here. But again, there you can see that it's returning something else that is not a dynamic array here, okay, when we're calling this map function. So that's why we need to do dot array. Give yourself little debugging helpers like this, like type ID, when you need. Okay, so with that said here, that's a bit of a digression here, but I'll save this in our result just so you can take a look at it if you want here. Let's go ahead and just delete that. There we go here. And I'll put a little helpful message here. Useful to check the type and observe that we are returning some sort of range object here. Okay. Okay. So we instead need to make a copy. Okay, so that was the point of doing the dot array there. Okay, so now that we've gotten that out of the way, I'll get rid of a few of these things here. Let's go ahead and take a look at some more cool stuff with the map function. And I'll do a lot of these by just writing them out. And again, now you know how to save a copy, because that's one of the advantages that we have here. But let's go ahead and write this function out in a different way here. And what if I just put a string here, do a times a? Okay, and let's try to write that out here. And that also works. We get the same result here. Because really what it's doing is I just need to initialize some sort of symbol here for some unary function, meaning just taking in one argument here. And I could name this A, or, you know, it doesn't really matter if it made more sense to make it a G or whatever. Oops, I guess it doesn't like G. I guess it does have to be A. Let's try that out if I do B or something. I think it might have to be the first A, and then if there's two arguments, then you can take B. Actually, I think that is true. So anyways, we have A here. But basically what this is doing is just applying the same function. So it's a little bit of a shorthand here. I put it in a string here so you don't have to have the lambda. So again, it's just a little bit of a convenience that you can do here. That's quite nice here. So anyways, let's play around with this just a little bit here. Let's go ahead and try to pass in something else here. And this is actually from the documentation, where what if I want to map all of my elements, so 1, 2, 3, 4, and just create a string from them. Okay, so we can actually do that. I believe I'll need to import the conversion library, as we've seen here previously. But now let's take a look at if that gives us 1, 2, 3, and 4 as strings, and indeed it does here. Okay, so that's quite fast. That's a small, you know, piece of code here. Didn't have to write a loop or anything fancy, but again, just another nice way to use map, as this might be something that you need to do, whether that's converting things to strings or some other format as needed. Okay, and again, that's kind of interesting because what if you have not integers, but some other structures in an array, and you need to serialize them or something? Again, you could just pass in a map, some sort of function to run that operation on all of your data. Okay, now it is also possible, instead of just calling these things, to call a regular function. So let's just go ahead and create a function here. I'm just going to call it, it needs to return an integer, double, let's times 2. It'll be a better name here. And I'll just take in some value here. And let's do something actually a little bit different, just so we know something we're calling. Times 4. And we're just going to return a times 4. And if we go down to the bottom here, let's go ahead and now, instead, let's just go ahead and call that times 4 function. And that's going to do so on each of our elements. So 1 times 4, 2 times 4, 3 times 4, etc. Okay, so that's the basic idea if you want to just pass in a function that takes in a single argument. The argument being, again, 1, 2, 3, and 4, successively called over and over again. All right, so we might actually want to make use of some of these different functions as well. I'm going to actually take this one. This is from the documentation. I thought it was nice here. I think they just call this string eyes, and then they say that this is going to be something that's called effectively on some sort of array. This is just going to be an alias, so a substitution. And let's see, so this is going to be a map function, and then we would just call to string. And then let's actually replace this here, just to show that it's going to do the same thing here. And again, basically do the textual substitution, string eyes. And, oops, let's see here. What did I misuse? I think just a semicolon. Classic. There we go. Oh, no property string eyes for array of type int. Okay. I think it's just not liking that UFCS universal function call syntax. Let's go ahead and see if this works here. Go ahead and see if I can string eyes. There we go. Okay, so anyways, that's a quick way to make this function here. That's going to call map on everything and make it to string. Again, same thing that we saw here. But again, kind of nice that we can just create these little aliases, which again is something that you could do for each loop, but you need to go ahead and put in a function and so on. So you can create these little sort of constructs here that are just kind of neat here. Now, the very last thing that I'll show you with map that I think is interesting is that we can actually use it on, or actually just call map once on a series of values like our array and actually generate different results here. So let's actually just write this out here. So I'm going to do array map. And I can actually pass in a times a. I could pass in times 4. I could do, let's see, what else did we do? A plus a or something like that here. And this is kind of neat here because, again, very concise here. Look what it returns here. Now I get this whole blob here, but this is basically a tuple with our results here. Okay, so let's go ahead and let's clean this up here. And I'm just going to, just to narrate a little bit what's going on here. Call map on our array with several different functions here. Okay. So what I'm going to do here this time is, let's just call it save or something here. I want to actually save this result here. Yeah, let's go ahead and save it as an array. What's it an array of? Well, I think you might have saw here. Let's go ahead and run it again. It's an array of tuples. So if I go ahead and write out the type ID of this, let's go ahead and see that. It is a tuple with, let's see, int as the type, because I'm computing an integer, and it's an array of those. Okay, so that's the idea here. And then let's go ahead and write out 0 and 1 and 2 here. Okay, just so you can see the individual tuples here. Actually, this doesn't give me quite what I want here. I think this is, we want to get rid of this dot array here, because it's just going to give me 3 values here. I mean, it's sort of working, but it's in a weird a times a times a times a order here. Times 4, times 4, times 4, and then 1 plus 1, 2 plus 2, 3 plus 3, etc. Let me actually just get rid of that here. Let's see here. Let me think about how to write that out into separate, because what you really want probably is the sequence 1 times 1, 2 times 2, 3 times 3, and 4 times 4 in the first value here. So there is a way that we could do this actually in a for each. And this is what the documentation does, something like this here. They just call it result. Let me call it save. Yeah, let's do this here. Let's see if this does the trick here. And see if this gives us closer to what we want here. 1, 2, 3, 4. And we'd have to do just a little bit more work here. But again, we can see 1, 4, 9, and 16, which are the values a times a here being applied just like we did before. So with a little bit more effort, and as we look at some more of the standard library, we could probably find out some clever ways to sort of unpack these tuples here. But we can see all the values here, and if we want to save them, then maybe we could do something more interesting here. But anyways, with that said here, that is just, in my mind here, kind of a nice way to look at some collection here, array of our data, apply several functions to it, and then get the results. And again, you could save them if needed. You could probably think of other, clever ways or things that you might do here. Like maybe this first function is actually writing out the data, and the second function is actually doing some sort of operation on it, and so on. And again, as mentioned, there are some interesting things that you can start doing with parallelism and map functions as well that I think just helps code be a little bit more clear than having to mess with different threads and so on. For parallelism, you can just do use a task pool and have a map function, for instance. So anyways, with that said, folks, hopefully you enjoyed this lesson, gave you a few different ideas about how to use map, why we use it versus for each, and where it can be useful. And again, it just exposes you to some of the more functional things that are available in the deprogramming webpage. Not the webpage, but the actual standard library. But that's a perfect transition to my webpage, courses.mshot.io, where you can sign up, track your progress on Dlang and other courses as well, if you're enjoying this series. So anyways, folks, with that said, thanks for bearing with me, and thank you. Hope you enjoyed that lesson, and stay tuned because we're going to talk about some of the more functional things as well and see how these come together. Alrighty, folks, thanks as always for your time and attention, and I'll look forward to seeing you in the next one.